Hi, we're going to do a volume of right prisms. So I want to talk a little bit about what a right prism is first. Easiest thing to think about is a cube. That is certainly a right prism. Basically, a right prism has a flat bottom, a flat top, and straight up and down sides. It's really easy to see what the volume is going to be here. There's 3 by 3 or 9 units on the bottom, and there are 1, 2, 3, so there's 9 cubes on the bottom and then 9 in the middle section and 9 on the top for 27. So that 9 times 3 gives me 27. And I always like to tell students, think of this as a building. The building's on here. But most buildings have a flat bottom, straight sides, and then a flat top. The same number of units, same number of rooms on every floor. So if you figure out how many floors are on the bottom and just multiply by how tall it is, if it's a right prism, that'll work. Another example of a right prism, this is basically a right prism because if I sit it this way, even though it's an irregular shape down here, it's straight up and down. Shape on the top is exactly the same. So maybe if this was 7.5 square units and I knew this was 10 tall, it's not, but if it makes the math easy, 7.5 times 10 would mean this would be 750 cubic units. Finally, one more example, not a cube, but a rectangular solid. Or what's called a right prism with a rectangular base. We always care about the base, so maybe this is 3 inches by 4 inches by 1 inch. So the bottom would be 3 by 4 or 12 square inches, and then times 1 inch be 12 cubic inches. If this was higher, too high, it would be 24. If it was 3 high, it'd be 36, because we multiply about how tall it is. So that's the basic idea. That's really all you need to know. I'm going to show you a couple of pictures, and then I'm going to very quickly talk about surface area. All right, so we have a right prism with a rectangular base that's 10 by 12. Sometimes they will show you a little dotted line so you can tell. They won't always. I don't have this labeled, so we're just going to say it's units. So 10 by 12 on the bottom is 120, and it's 5 high, so it's like I've got 120 rooms on the ground floor. There's 5 floors. 120 times 5 is 600. So 600 little square units would fit inside this box. Not square, sorry, cubic units would fit inside this box. Another example you're going to see in a minute is the same thing, but instead of a rectangle on the bottom, you may see a triangle on the bottom. And depending on the case, it may be hard for somebody to draw this for you. I'm going to try to do this. I'm probably going to do it badly. Okay, we're going to do this, and I'm going to do this. I'm going to do a little dotted line, so you know it's a triangle back there, and I'm going to put a little right angle on the top, so you know this is basically if I was to flip this down, that front side would be like this, that side would be like this. That thing's a right triangle at the bottom. Doesn't matter what the shape of the bottom is as long as you can figure out the area of the base. If you know the area of the base times the height, that is the volume. Okay, so don't get hung up. Sorry, you can't see that. You don't get hung up on the formulas. Just figure out, well, do I know the area of the base? How tall is this thing? Let's see. I had some numbers written down. Oh, so once again, pretend this is 10 by 12. Doesn't look the same size, but say it is. This is supposed to be 10 by 12. I know that's getting hard to read. My marker's a little smudgy. So it's a triangle. So instead of 120 on the bottom, it's going to be 60 on the bottom because it's half of that 10 times 20. And then if it was still the 5 high, it would be 60 times 5. So this one down here would be 300, which is what we expect because it would be exactly half of the 600 units cubed that we have up there, because it basically was this thing kind of chopped in half. I want to mention this formula, this area base times height. It works if it's a rectangular prism. If it is a cone or anything that's pointy, it doesn't work. If this building is tilted, think like it doesn't have straight up and down sides, the formula doesn't work for that. It kind of does, but not really. So this is specific to right prisms. Now, very quickly, surface area. Surface area is like perimeter, but in 3 dimensions. What are the area of all of the surfaces? It sounds exactly like it is. So this one, there's 9, and I've got 1, 2, 3, 4, 5, 6 surfaces. So 9 times 6 is 54. That's the surface area of that. 54 square units cover this thing. For this particular one right here, the made up numbers I had were 3 by 4 on the bottom, so that thing's got an area of 12. This would be 3 by 1, so that's got an area of 3. and this one's got a 1 by 4, so that's got an area of 4. So 4 plus 3 is 7, and the 12 is 19, and then I've got 3 other surfaces I've got to count. So the 19 plus the 19 is going to be 38. So 38 square inches, I think I said it was inches, would cover this whole box if in fact this was 3 by 4 by 1, which is probably not quite, but okay, that's enough. Ciao.